Hi, in this video we are going to be learning all about right angle triangles. For a right angle triangle, as what you can see here, one of the angles is already given as 90 degrees. Okay, for such triangles, there are four main rules regarding the solution for the sides as well as the angles. The first rule we're going to be talking about is what we call the Pythagoras theorem. This Pythagoras theorem has been around, okay, for ages, and it actually helps us to find the sides, all right, the sides of the right angle triangle. The rule basically says that, okay, so first let's label the sides. So I'm going to call this A, B, and C. Okay, now the rule involves the usage of the hypotenuse and the other two sides. So what is the hypotenuse, or which side is what we call the hypotenuse? The hypotenuse, okay, in short form, we just put it at HYP, hypotenuse, is basically the side that is directly opposite the right angle. So as you can see, the right angle is here, and if I were to draw a line, okay, from the right angle looking outwards, the side that is directly opposite is C. Alright, that is one way in which you can identify the hypotenuse. Now I'm going to teach you another trick where you can always make sure you get it right. Imagine, okay, or what you can do is you can put your hand, alright, and cover this right angle over here. So if I put my hand over here, okay, and let me just color this hand. So what do you see? When I put my hand on this right angle and I cover it, this hand is actually going to be touching two of the sides. Okay, so a triangle has three sides. When I put my hand, it actually covers two sides, this side here and this side over here. So the side that my hand is not touching is this side here, and that is the hypotenuse. Okay, so this is a very easy trick that you can use anytime. Just put your hand and cover the right angle, and your hand will be touching two sides of the triangle. Okay, the side that is not touched by your hand, that is the hypotenuse. Okay, so that basically is a very useful and easy trick to help you find out the hypotenuse of any triangle. Now let's move on to seeing how we can apply the Pythagoras theorem. So the Pythagoras theorem says, okay, so let me put it in words first. It says the square of the hypotenuse is equal to the sum of the square of the other two sides. Okay, the square of the hypotenuse is equals to the sum of the squares of the other two sides. Okay, so to put that mathematically, basically it means that the square of the hypotenuse, which is c square, is equals to the sum of the squares of the other two sides, which are A and B. Alright, so let me repeat that again. Pythagoras theorem basically says that the square of the hypotenuse, which is C in this case, the square of it is equals to the sum, the addition of the squares of the other two sides. So A square and B square. Okay, A and B here. So that is basically your Pythagoras theorem. As you can see, the Pythagoras theorem focuses on the sides. It focuses on the sides. at any point of time, as long as you know two of the sides, you can easily find the third side, okay, the third unknown side, using this theorem alone. All right, so there are a lot of examples on my website, okay, on how the Pythagoras theorem has been applied to solve the sides of a right angle triangle. So you can look at those questions, okay, to see how we can actually use this theorem to solve those questions. Now let's proceed on to understanding the other three rules. So I mentioned there are four rules. The first rule is regarding the side, that is the Pythagoras theorem. The other three rules are actually regarding the angles, okay, regarding the angles. So let me put the right angle here first, okay, and I'm going to label them as before: A, B, and C. So with one of the angles being already known as given as 90 degrees, we have two other angles that also add up to 90 degrees. All right, and we can label these angles. Okay, so let me just label one angle first. So I'm going to call this angle theta here. Okay, now the three before we go on the three rules, what we must first understand is the concept of the other two sides. Okay, so we know that for any right angle triangle, there are three sides. The first one is the hypotenuse, which is already fixed. So for this triangle over here, we can say the hypotenuse is C. Okay, and this is fixed, is always going to be C. The other two sides, all right, are what we call the opposite and adjacent. Okay, opposite and adjacent, and the opposite and adjacent sides are actually relative to the angle. Okay, relative to the angle you're talking about. Okay, so let me show you how, okay, you can find out the opposite and the adjacent for any angle. Now let's take theta. Okay, so now we're going to be focusing on theta. So for any angle, like I said, the hypotenuse is already fixed. Okay, so the hypotenuse is equals to C. That is already fixed. Now, how do I find the opposite? To find the opposite, okay, of theta, okay, what you need to do is you need to apply the same technique we used to find the hypotenuse. Okay, the same technique we used to apply the hypotenuse, which means you take your hand and you cover up this angle here. Okay, you take your hand and cover up this angle here, and when you cover up theta, what do you see? You observe that your hand touches two sides of the triangle. One is this side, the other is this side here, and the side that is not being touched by your hand is this side here. So that is the opposite. Okay, the opposite for angle theta. Alright, so the technique is the exact same technique we used to find the hypotenuse. Only thing is now we are applying it to another angle. So now we are talking about angle theta, and for angle theta I want to find the opposite. Alright, so I put my hand on top of angle theta, and my hand is touching two sides. Alright, and the side that is not touched by angle theta, that is my opposite. Okay, for angle theta. So for theta, my opposite is B. So that is the technique to find opposite. Now I'm going to talk to you about the technique to find adjacent. Okay, to find adjacent. For adjacent, all you need to do is look at the angle that you draw here. That means this line here. So you draw an angle, you actually draw a curved line that touches two sides. correct? So for theta, when I draw this curved angle here, I'm actually touching two sides. All right, one of the sides is actually the hypotenuse. Again, the hypotenuse, like I said, is already fixed for that particular right angle. The other side that your curved line is touching, that would be the adjacent. So in this case, for theta, the adjacent is 8. Okay, so that is so those are the two very easy techniques you can use to find out the opposite and adjacent for any angle. All right, now I'm going to apply this same technique, okay, for the other angle over here, and I'm going to label this angle as alpha. Okay, so there's another angle here, angle alpha, and for angle alpha, what I'm going to do is I'm going to go through the same technique of finding what is the opposite and the adjacent. So to find the opposite of angle alpha, all right, the technique is, as what I mentioned, you can put your hand on top of this angle and cover it. Okay, so let me draw the hand here. Okay, and I'm going to color it. So when I draw my hand on top of this angle and cover it, you can see that it is actually touching two sides, here and here. And the side that is not being touched by my hand is A. Alright, so the opposite, okay, is A. Okay, so it's the exact same technique as what we did just now. Okay, I'm just going to write on the hypotenuse. So the hypotenuse here is fixed at C, as what I mentioned. The hypotenuse is always the same, all right, for that particular right angle triangle. All right, so for alpha, the opposite is A, and to find the adjacent, the technique is again very simple, as what I mentioned just now. You look at the curved line that you draw for the angle. So this is the curved line that you draw for the angle, and this curved line is going to touch two sides, and one of the sides is definitely going to be the hypotenuse, correct, which is C. So the other side that my curved line touches, that is the adjacent. So in this case, the adjacent for angle alpha is B. Okay, so this is the important technique you must know very well. For any angle, how do I find out the opposite and the adjacent? Okay, so this is very, very important. Okay, now after you find the opposite and adjacent, what can we do next? Okay, what can we do next? Okay, so let's look at the angles and how we can find them. Okay, so for any right angle triangle, okay, so let me copy this triangle over here. Okay, so now what we are going to be focusing on is the analysis of the angles, okay, for theta and alpha. So for angles in a triangle, there are three main type of formulas that we are going to be using. They are what we call the tangent, sine, and cosine. Okay, and basically you just need to know these three rules. For tangent, it is opposite over adjacent. For sine, it is opposite over hypotenuse, and for cosine, it is adjacent over hypotenuse. Okay, so there are a lot of different techniques to memorize this. Okay, it's up to you to figure out some acronym that is easy for you to remember. The one that I was taught when I was learning all this, I still remember it. It basically was called TCS, to represent tangent, cosine, and sine. And how we remembered these relationships were by this sentence called Tua, Ka, and So. So as you can see, tangent is opposite over adjacent, cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. Okay, so this is how I was taught, and it works pretty well, and I still remember it very clearly until now. So you can come up with your own acronym, okay, as long as you remember the relationships between tangent, sine, and cosine. Okay, so now if I were to take angle theta, okay, so let's see how we can apply this. So for angle theta, okay, if I were to look at tangent theta, okay, so for tangent theta, it is opposite over adjacent. So we just established that for theta, B is opposite, A is adjacent. So tangent theta would be B over A. Okay, sine theta would be equals to, sine theta is opposite over hypotenuse, which is B over C, and finally cos theta. Cos theta would be adjacent over hypotenuse, A over C. Okay, so that is how you apply the opposite and adjacent with relation to the appropriate angles here. The next angle I'm going to talk about is angle alpha. So for angle alpha, okay, what you have for tangent theta? For tangent theta, you have tangent alpha here. For tangent alpha, what you have is, the rule says tangent is opposite over adjacent. So maybe let me just put it as an angle here. So you're actually performing all of these operations on angles. Okay, now for tangent alpha, you can say that it is given that it's opposite over adjacent, so it is A over B. Okay, A over B. For sine alpha, sine is always opposite over hypotenuse, A, which is opposite, over hypotenuse C. Okay, and finally cos theta, cos alpha. So for cos alpha, cosine is given as adjacent over hypotenuse. So for alpha, adjacent is B, hypotenuse is C. Alright, so as you can see, the important step is first understanding what is the opposite and adjacent for any of the angles in the right angle triangle. Alright, the hypotenuse is fixed. Okay, and then you must know what is the opposite and adjacent for each of the other angles you are referring to. And for each of those angles, you can then come up with the relationships of the tangent, sine, and cosine. Okay, in my website, you can definitely see a lot of questions where we have used the Pythagoras theorem as well as this tangent, sine, and cosine angles formulas to solve many different questions. So please have a look at those questions and learn how you can become a pro at solving such trigo questions. So thank you very much for watching, and I will see you soon in the next video. Thank you. Bye.